This is 1-5 continued. In the last video, you learned how to solve inequalities, and now we're going to talk about how to take those solutions and put them on the number line and the different notations. So first thing you want to notice is there are 4 different symbols. There's the greater than or equal to, the less than or equal to, the less than, and the greater than. These two symbols, this line up underneath, means it can also be equal to. If we need to graph and our solution has a symbol that has the equal to part, we want to make sure when we're graphing, we create a closed dot. That means you take a circle and you color it in. And I'll tell you exactly how to do that in just a minute. And then if it does not have the equal to line up underneath, if it's just greater than or less than, this is the less than, or greater than, you want to leave the dot open. You don't want to color it in when you're graphing. So, for example, if we have x is greater than or equal to 4, we'll draw a number line that has the number 4 marked clearly. And since 4 is our solution, we look back over here and we say, okay, it's got the equal to, so I need a closed dot directly on top of 4. And now we just shade in the direction for the solutions. The x values are greater than the 4. So we need to shade where values would be greater than. If I go back this way, that would be 3, 2, 1. If you follow a number line, you'd go 3, 2, 1, 0 to the left, but as we go to the right, 5, 6, 7, 8, and so on. So we want to shade in the direction where the numbers are greater than 4. So that's how you graph on a number line. Let's try another one. If we have n is less than 2, well, our number line is drawn where we have 2 clearly marked. And since we aren't equal to, there's no equal, we want to make sure we do an open dot on the 2. And the values that will work here, that will make this statement true, are all the values that are less than 2. So we want to go that direction. We want to go less than. So notice I just shade the number line in that direction. I have seen students do this, and this is okay as long as your dot is closed or open, depending on the symbol. If you want to draw an arrow and go up like this, that is okay. And an arrow back like this, that is also okay. Now let's talk about set builder notation. Sometimes you're not going to be asked to graph. You might be asked to write in a certain notation, in this case set builder. Set builder notation always starts with a brace. It's a curly parentheses. So you open the brace and then you put in the variable that we're talking about. So in this case here we're going to solve for w. So the variable that I would write first would be a w. This line here means such that. And really all that's saying is, hey, I'm solving for this variable, and now I'm going to tell you about the solutions. So we'll write the variable again and write whatever the solution was. So if I come back up here, if I were to write this solution in set builder notation, I would write a curly brace, and x is the value or the variable that I'm solving for, so x such that, draw that straight line, x is greater than or equal to 4, and then close your brace. In this case, I would write brace n such that n is less than 2. So really all you're doing is putting it in set notation, and you're just defining what the answer is, but you're just taking whatever this is and putting it over here. Okay, so let's solve this inequality. Get all your w's on one side and all of your constants on the other side. So I'm going to subtract 4w from both sides, and I'm going to move the 3 to be with the 9, so -3 and -3. So I'll have W on the left is greater than 9 minus 3 is 6. Now, that was solving it. If I wanted to graph it on a number line, I would put the 6 here. Since it's greater than and there is no equal to, I would do an open dot. And I want to shade greater than goes to the right, all the numbers greater than. And if I wanted to write it in set builder notation, I would do the curly brace, W, such that, well, what is true about W? W is greater than 6, so W is greater than 6. Set brace. This is set builder notation. Flip over and let's talk about interval notation. So with interval notation, again, you look at your 4 symbols. If you do not have the equal to underneath, you're going to use parentheses. If you do have an equal to underneath, you are going to use a bracket. Okay, so first what I have to do, I have to draw it on the number line because I am a visual person. So when I draw x is greater than 2, I do the 2. I do an open dot because there's no equal to. And since this says greater than, I go to the greater side of 2. And now I look at this and I say, okay, where can I start? Well, I can start at 2 and then my arrow goes to the right. There's no solutions on the left side of 2. So I start at 2 and then I ask myself, well, can I be equal to 2? And this right here says no because there's no equal to. And also my open dot clearly shows that there's no equal because it's not colored in. Since it's not equal to at that point, I have to give it a parentheses because I have to follow these instructions here. Now, put a comma and you look at your arrow and say, well, where does it end? Now in this case, it never ends because my arrow shows it's going to continue on forever and ever that way. So it's going to go to infinity. And since you can never be equal to infinity, you need to just go ahead and close it with a parentheses. Okay? This one right here, I'm going to change this to say less than or equal to so you can see it differently. So x is less than or equal to -5. So I'm going to draw a -5 here. And since it's equal to, we're going to do a closed dot. And we need to draw our arrow going less than, so to the left is less than. And now in interval notation, well, where is the starting point? Since all my solutions are all the way to, you could keep going and going and going forever to the left, which is all those lower or smaller values, we would say there's no real starting point. So I'm coming from negative infinity. Now, can I be equal to negative infinity? No. So you need an open parentheses on that side, comma, where do I stop? Well, I'm coming from negative infinity. If I drew my line out, I'm coming from negative infinity, and I stop at -5. And can I be equal to -5? Based on what we said here and the closed dot, yes, you can, so you do a bracket. Okay, let's try this last one. I'm going to move the 4 over so I don't create any negatives. So I'm going to combine my like terms. And then I'm going to bring the 2 over here by subtracting. So I have -5 is less than y. Now the way that I have it written, if you want to change it back around so that you can see it from the variable, you always need to look at it from the variable. In this case, y is greater than, the big part is next to the y, so y is greater than the -5. But a lot of students get confused with that, so you can go ahead and rewrite it like this. Just make sure if the open part is towards the y, that it's still towards the y when you flip it around. Let's draw a number line, -5, and we're looking for greater than the -5, no equal to, so open dot, greater than, shades to the right. This says, then write your answer in set builder and interval notation. So set builder would be brace. Y is our variable such that this right here defines where the solutions are. Y is greater than -5. Close your brace. That's set builder. Interval notation is starting at -5. We have an open parentheses, and we can go forever and ever all the way to infinity, but we cannot ever be equal to it, so open parentheses. This is set builder, this one's interval notation, and this is our number line. All right.